Inferences for two population means using paired samples. Distribution of the paired t-statistic. Suppose that X is a variable on each of two populations whose members can be paired. Further, suppose that the paired difference variable D is normally distributed. Then, for the paired samples of size n, the variable t equals d bar minus, open parenthesis, mu sub 1 minus mu sub 2, close parenthesis, all divided by s sub d square root n, has the t distribution with degrees of freedom n minus 1. In this case, d bar is the difference average. Paired t-test. Purpose: to perform a hypothesis test to compare two population means mu sub 1 and mu sub 2. Assumptions: 1. Simple random sample. 2. Normal population or large sample. Paired t-test. Step 1. The null hypothesis is h sub 0 colon mu sub 1 equals mu sub 2, and the alternative hypothesis is h sub a colon mu sub 1 does not equal mu sub 2, two-tailed. Or h sub a colon mu sub 1 less than mu sub 2, left-tailed. Or h sub a colon mu sub 1 greater than mu sub 2, right-tailed. Step 2. Decide on the significance level alpha. Step 3. Compute the value of the test statistic and denote that value of the test statistic t sub 0. T equals d bar divided by s sub d divided by the square root of n. Paired t-test using critical values. Step 4. The critical values are plus or minus t sub alpha divided by 2, two-tailed. For a two-tailed test, our rejection region is to the left of negative t sub alpha divided by 2 and to the right of t sub alpha divided by 2, and each area is alpha divided by 2. Or negative t sub alpha left-tailed. For a left-tailed test, the rejection region is to the left of negative t sub alpha, with the rejection area being alpha. Or t sub alpha right-tailed. For a right-tailed test, the rejection region is to the right of t sub alpha, with the rejection region being alpha. With degrees of freedom equal n minus 1. Use the t-distribution table to find the critical values. Paired t-test using critical values. Step 5. If the value of the test statistic falls in the rejection region, reject h sub 0. Otherwise, do not reject h sub 0. Step 6. Interpret the results of the hypothesis test. Paired t-test using p-value approach. Step 4. The t-statistic has degrees of freedom equal n minus 1. Use the t-distribution table to estimate the p-value or obtain it exactly by using technology. The p-value for a two-tailed test takes the area to the left of negative absolute value t sub 0 and adds it to the area to the right of positive absolute value t sub 0. The p-value for a left-tailed test is to the left of t sub 0. The p-value for a right-tailed test is to the right of t sub 0. Paired t-test using p-value approach. Step 5. If p is less than or equal to alpha, reject h sub 0. Otherwise, do not reject h sub 0. Step 6. Interpret the results of the hypothesis test. Note, the hypothesis test is exact for normal differences and is approximately correct for large samples and non-normal differences. Example using critical values. The null hypothesis is H0 colon U1 equals mu2, and the alternative hypothesis is H colon U1 does not equal mu2. The provided data are from a simple random paired sample from two populations under consideration. Use the paired t-test to perform the required hypothesis test at the 10% significance level. Observations from, and we have pair, population 1, population 2. For pair 1, population 1 is 14, population 2 is 12. For pair 2, population 1 is 22, population 2 is 21. For pair 3, population 1 is 16, population 2 is 13. For pair 4, population 1 is 12, population 2 is 6. For pair 5, population 1 is 24, population 2 is 20. Pair 6, population 1 is 6, population 2 is 7. For pair 7, population 1 is 13, population 2 is 10. Because H is mu1 does not equal mu2, we have a two-tailed test. Step 1 was provided for us in the original problem. H0 is mu1 equals mu2, and H is mu1 does not equal mu2. Step 2, alpha equals 0.1. Step 3, compute the value of the test statistic and denote that value T0. In order to use our formula, T equals the mean of D divided by the standard deviation of D divided by the square root of n, we need to know the mean of D and the standard deviation of D. In order to do this, I need to find D. D is population 1 minus population 2. In the table, with the pair population 1 and population 2 as the columns, but we're also going to add a column D sub I, and we want to use our calculator to help us find that value. Stat, edit menu, 1 edit. Under L1, I want to type population 1, 14, 22, 16, 12, 24, 6, 13. Moving over to L2, I want to type in population 2, 12, 21, 13, 6, 20, 7, 10. Move over to L3, then up, and now I'm ready to find D sub I, which is the difference between population 1 and population 2. Second 1 gives me L sub 1 minus second 2 gives me L sub 2, enter, and now I'm ready to take this column and move it to my table. For pair 1, D sub I is 2, for pair 2, D sub I is 1, for pair 3, D sub I is 3, for pair 4, D sub I is 6, for pair 5, D sub I is 4, for pair 6, D sub I is -1, for pair 7, D sub I is 3. I'm going to use my calculator to find the mean and standard deviation. Stat, over to Calc. We want one variable statistics. The default is L1. We want to find the average and standard deviation of L3. Second, 3 types in L3, enter, and I have a mean of 2.5714, and we want the sample standard deviation of 2.22539. Rounding to 3 decimal places, d bar equals 2.571 and S sub d equals 2.225. We're ready to substitute into our t formula. 2.571 divided by 2.225 divided by the square root of 7. You want to be careful and make sure you have your denominator in parentheses. 2.571 divided by, open parenthesis, 2.225 divided by second, then square root, 7. Either close your parentheses or arrow right, close parenthesis, enter. And our answer is 3.057. Step 4. Identify the critical value with degrees of freedom n-1. We have a two-tailed test. Our degrees of freedom would be 6. And we want to find plus or minus t sub alpha divided by 2. Since alpha is 0.1, we want plus or minus t sub 0.05. Going to our table, we want to go to row 6 and column t sub 0.05, which is 1.943. which gives us plus or minus 1.943. The critical value is plus or minus t sub alpha divided by 2 equals plus or minus 1.943. Step 5. If the value of the test statistic falls in the rejection region, reject H sub 0. Otherwise, do not reject H sub 0. The critical values are negative 1.943 and 1.943. The test statistic is t equals 3.057, which is to the right of 1.943. It falls in the rejection region. Reject H sub 0, the null hypothesis. There is sufficient evidence that mu sub 1 does not equal mu sub 2. Example using p-values. The null hypothesis is H sub 0 colon u sub 1 equals mu sub 2, and the alternative hypothesis is H sub a colon u sub 1 less than mu sub 2. The provided data are from a simple random paired sample from the two populations under consideration. Use the paired t-test to perform the required hypothesis test at the 5% significance level. For my table, we have observations from pair 1, population 1, 13, population 2, 17, pair 2, population 1, 21, population 2, 25, pair 3, population 1, 16, population 2, 18, pair 4, population 1, 26, population 2, 22, pair 5, population 1, 25, population 2, 30, pair 6, population 1, 25, population 2, 26, pair 7, population 1, 6, population 2, 8, pair 8, population 1, 18, population 2, 26, pair 9, population 1 is 2, population 2, also 2. Step 1 is given. H sub 0 is mu sub 1 equals mu sub 2, and H sub a is mu sub 1 less than mu sub 2. That means we have a left-tailed test where t sub 0 is to the left of our mean 0 and our p-value is the shaded area to the left of t sub 0. Step 2 is alpha equals 0.05, since the significance level is 5%. Step 3. Compute the value of the test statistic and denote that value t sub 0. Our formula is t equals the mean of d divided by the standard deviation of d divided by the square root of n. We need the mean of d and the standard deviation of d. In order to do that, we need to find d sub I for each pair, which is population 1 minus population 2. Then find the mean and standard deviation of that column. We're going to use our calculator. Stat, edit, 1 edit. We want population 1 in L1. 13, 21, 16, 26, 25, 25, 6, 18, 2. L2, we want population 2, 17, 25, 18, 22, 30, 26, 8, 26, 2. I've noticed a mistake, so I'm going to arrow up to the 222, change that to 22, enter. Now I'm ready to find the difference. Heading over to L3, arrow up, I want to subtract L1 and L2. L1 minus L2, enter, and I have my difference. I can put that in my table. For pair 1, the difference is -4. For pair 2, the difference is -4. For pair 3, the difference is -2. For pair 4, the difference is 4. For pair 5, the difference is -5. For pair 6, the difference is -1. For pair 7, the difference is -2. For pair 8, the difference is -8. And for pair 9, the difference is 0. I can add these up and divide by 9 to find my mean, or I can use my calculator. Stat, over to Calc, 1 variable statistics. My list that I want to find the mean and standard deviation of is L3. There isn't a frequency list. I'm ready to calculate. And my mean is 2.44, and my sample standard deviation is 3.395258. Using 3 decimal places, d bar equals -2.444, s sub d equals 3.395. Now we have enough information to find our test statistic. T equals, substituting, -2.444 divided by 3.395 divided by the square root of 9. -2.444 divided by, open parenthesis, 3.395 divided by second square root 9, and either arrow right or close your parentheses, close parentheses. Rounding, we have -2.16. Step 4. The test statistic has degrees of freedom n-1. My degrees of freedom are 8. It is a left-tailed test, so my p-value will be to the left of t equals -2.16. Going to our calculator, second, Distribution, we want T CDF, enter. Our lower limit is going to be a really small number. I'm going to use -1000. Our upper limit is going to be -2.16, and our degrees of freedom are 8. Enter, enter. Rounding to 4 decimal places, p equals 0.0314. The p-value is 0.0314. Step 5. If p is less than or equal to alpha, reject h sub 0. Otherwise, do not reject h sub 0. So we're ready to compare our p-value to alpha. 0.0678 is greater than 0.05. The p-value is greater than 0.05. So that means we do not reject h sub 0, the null hypothesis. There is insufficient evidence that mu sub 1 is greater than mu sub 2. Paired t-interval procedure. Purpose: to find a confidence interval for the difference between two population means mu sub 1 and mu sub 2. Assumptions: 1. Simple random sample. 2. A normal population or large sample. Paired t-interval procedure step 1. For a confidence level of 1 minus alpha, use the t-distribution table to find t sub alpha divided by 2 with degrees of freedom equal to n minus 1. Step 2. The endpoints of the confidence interval for mu sub 1 minus mu sub 2 are d bar plus or minus t sub alpha divided by 2 times s sub d divided by the square root of n. Step 3. Interpret the confidence interval. Note: the confidence interval is exact for normal differences and is approximately correct for large samples and non-normal differences. Example: a group of 8 students were given the same standardized test twice to see whether retaking the tests affected the score. The table gives the score differences for the 8 students. Use the paired t-interval procedure to determine a 99% confidence interval for the difference between the mean scores on the first test and the second test, which is the retake. Note: d bar equals 8.75 and s sub d equals 32.71. My data set is -10, 60, -20, 30, -20, -10, 50, -10. Step 1. For a confidence level of 1 minus alpha, use the t-distribution table to find t sub alpha divided by 2 with degrees of freedom equal to n minus 1. For 99% confidence interval, alpha equals 0.01 with degrees of freedom 7. To find t sub alpha divided by 2, we divide 0.01 by 2, and we want to find t sub 0.005. Going to our table, looking at row 7, in column t sub 0.005, we have 3.499. So t sub alpha divided by 2 equals 3.499. Find the 99% confidence interval. Step 2. Find the endpoints of the confidence interval. That formula is d bar plus or minus t sub alpha divided by 2 times s sub d over the square root of n. Substituting, I have 8.75 plus or minus 3.499 times 32.71 divided by 8. Calculating the information to the right of our plus or minus, 3.499 times 32.71 divided by square root 8, enter. I have 40.464995, which gives us 8.75 plus or minus 40.46. Step 3. Interpret the confidence interval. That means we need to find the value that is 8.75 minus 40.46 and 8.75 plus 40.46. The 99% confidence interval is from negative 31.71 to 49.21. Recapping, inferences for two population means using paired samples. Distribution of the paired t statistic. The difference here is how we find the test statistic. It is t equals d bar minus parentheses mu sub 1 minus mu sub 2 close parentheses all over s sub d times the square root of n, where the degrees of freedom is n minus 1.